You could kind of sum up the challenges we face, technological and scientific, just by kind of thinking about what we're trying to do. So we're trying to take a sediment core a few meters long in a place that's dark. It's down the bottom of a hole which is this diameter but 3 kilometers long, and then 160 meters of water or so. It's under incredible pressure, it's cold, and of course at the surface where we're trying to do all this is about minus 20 degrees, it's incredibly windy, and it's just a really difficult place to work. I mean, Antarctica is always a difficult place to work. And to throw into all of that, we've got to keep everything clean. Both everything that goes into the hole has to be clean, and when we extract things, we of course want to keep those protected. So it's a series of challenges, and the design has had to reflect all of those.
One of the major challenges is obviously to get a sediment core from this very remote environment, and we need a way of driving that core into the sediment. Traditionally in oceanographic research, you would just rely on a massive weight, so you'd have a 10-ton weight, or you would have a vibrating system, but these are also very large. Those two ways of driving a sediment core into the sediment aren't available to us because we have this very small hole we have to operate down. So we've had to develop a percussion hammer that is a very narrow device but has enough force to drive into what could be very stiff glacial clays. And that's taken several months of design, and now we've got a prototype with our Austrian partner, and we've tested that, and we've got a hammer design that can push that sediment core into the sediment. But of course there are a number of other challenges. We can't necessarily image the bed in the way that you would from a ship. You would have sonar devices to tell you exactly where the floor of your lake or your marine sediment was. We can't do that because we can't image through the ice sheet in the same way in real time. So we need to have a camera positioned right on the end of the core with a light source, so that will film the descent of the core down through the ice hole, down through the water column of the lake. And it's actually only when that image on that camera disappears that we know we've touched the sediment. And at that point we can start coring. So we've had to design features like that. Also, because we've got an electromechanical hammer, we have to supply power to that. And if you supply power down a long cable, that power the power is quite different once it's been transmitted down the cable, and it has to be conditioned in the core to have the right characteristics to drive the motors. So we've had to do some electromechanical engineering in order to get that power sorted out correctly. We need the optical signals we're going to have a camera on the bottom and a camera on the top of the core. We need other signals to drive component parts of the core that help it carry out its operation. So there's a whole series of complexity that has been brought about by the fact that we have to operate down this very narrow hole with a single cable a long way from the surface.
The reason why we're trying to keep the cleanliness issue is so important, there's two reasons. One is scientific, and the other one is if you like, it's ethical or environmental. So the scientific reason first is that we're testing for the presence of life, and it's likely to be microbial life and possibly something a little bit bigger, but it's going to be pretty small stuff. If we take down a really dirty piece of equipment that's covered in microbes and bacteria and so on, we won't know whether we found truly life in the lake or whether we've just discovered something that we took down into the lake with us. So it has to be clean for that reason. The second reason is an environmental one, where we know from a number of years of research that water is moving around underneath the ice sheet. And what that suggests is if we introduce some sort of contamination beneath the ice sheet at Lake Ellsworth, it could spread. You know, we could transfer that contamination out in the ice sheet. And the way that the Antarctic is managed, it's managed in an environmentally sensitive way, and we have to meet very stringent standards in terms of cleanliness. And we're leading the way on this, and there's a group of about 50 nations are looking at the proposal we've made to ensure that it's clean enough.